I'm John Manier from Accu-Slice. This video will be part 5 of the video series on the development of this Automated Accu-Slice System for the automatic slicing of boards on the bandsaw. In the previous videos we described the design of the system and the manufacture of the system. Now I'll be starting another series on the development of the software to control the system and to fully automate its operation. We built a prototype of this several years ago in which I developed an electronics console for the control of the system. This electronics console consists of a box with electronics inside, which consists of an Arduino board and a bunch of switches and relays. And then there's switches and relays on the front of the box, a series of lights, and a small LCD display to show you the status of the system. In the next version of the Automated Accu-Slice System, I'll be replacing this entire electronics console with a new console. It will consist of an Arduino board for the main software operation and control, but the front panel will be totally different. I'll be using this 7-inch touch pad screen for the control and operation of the system. On the screen you'll be able to set your parameters such as your curve of your blade, your board thickness, and various operational parameters of the system. It will also enable you to fully control the operation of the system. I'll probably be producing at least 2 videos on the development of the software to control this Automated Accu-Slice system. This first video will describe the development of the screen display, the design of the screen, and then the parameters that are used to control the operation of the system. A subsequent video will actually describe the development of software to actually control the operation of the system. The hardware for the operation of the Automated Accu-Slice system consists of 2 major components: the Nextion Touch Display panel and the Arduino electronics control board. Both of these systems, along with the drivers for the stepper motors, the power supplies, the relays, and the other electronics components, will all be housed in the electronics console, which will be designed and built in the next video. The 5-volt output from the Arduino board does not have enough current to power the Nextion display, so I needed to add the 24 to 5-volt DC converter in order to supply the voltage and current needed for the Nextion display. When I first set up this system, I had one major problem, in that I had no communication between the Arduino board and the Nextion display. I was able to design the displays, but I was not able to download any data between the display and the Arduino board. I discovered that the problem was due to the 5-volt supply to the Nextion display by the 24 to 5-volt converter. It turned out that the grounds on both the Arduino board and the Nextion display panel needed to be connected together. When I added the white jumper wire between the ground on the Arduino board and the 5-volt output from the 24 to 5-volt converter, the system worked perfectly. But this took me some time to figure out this problem. The remainder of this video will demonstrate the development of the Nextion screens for the Automated Accu-Slice system. This schematic shows the various components of this Automated Accu-Slice system and how they are integrated together to develop this system and to enable the input and output of data and to control both the manual and the automatic operation of the Automated Accu-Slice system. I'll be using 3 software packages to develop the software to control the operation of the Automated Accu-Slice system. The software packages include Photoshop for design of the graphics, the Nextion Editor, the software for the display monitor, and the Arduino IDE software to program the Arduino electronics module. I'll be using the Photoshop graphics software to develop the screens for the Nextion Touch Pad Screen. The screens shown here are some initial ideas of proposed background screens and other graphics, but these will undoubtedly be modified or changed as I continue to develop the programs to control the system. After the screens and other graphics are designed, they are saved and downloaded to the Nextion software package. The Nextion software is then used to further design the display pages. Multiple pages are being set up for the operation of our system. For example, we have separate pages for the inputting of data to the system, the manual operation of the system, and the automated operation of the system. These pages or screens are being designed to eliminate or replace many of the button switches and LED lights that were designed into the original electronics console that was described for the first version of the Automated Accu-Slice system. The Nextion software is then used to add the background images to the various pages. Additional fields are added to these pages to display operational data, and a variety of buttons are added to control the operation of the system. These pages can be modified at any time, and I will probably change these pages several times as I continue to develop the software for the control of the Automated Accu-Slice system. The Nextion software program is then downloaded to the Nextion Touch Pad Screen display panel. The Nextion Touch Pad display enables the setting up of various parameters such as the feed rates for the linear stepper motor driver, the parameters and the quantities for the thickness of the boards being sliced. This data can then be input into the system via the touchpad display. Various screens are then used to display and control the operation of the Automated Accu-Slice System, with feedback showing the real-time status of the system. The Arduino software is then set up to enable the communication between the display panel and the Arduino electronics board. Programming both the Nextion software and the Arduino software is needed to allow the two systems to communicate with each other for the input and output of data for the operation of the system. This is a two-way communication where data is sent from the Arduino board to the Nextion display panel, and likewise, Arduino board can send data to the Nextion display panel. The Arduino board is then interfaced to the Automated Accu-Slice System to control the operation of the Automated Accu-Slice System. In the next video in this series, I'll describe the development of the Arduino software to control the operation of the Automated Accu-Slice System and the development of the electronics console. I began by designing the background in Photoshop. I found an image of a nighttime sky and then superimposed the Accu-Slice logo on top of the base image. I played with the contrast, lightness, and darkness to get the contrast that I desired. I also adjusted the hue and saturation to see what color I preferred for the system. I ended up settling on the dark blue image. I may need to adjust the contrast and darkness later to get the contrast that I desire for the touchpad display. I also had the option of putting some graphics on the screen using the Photoshop software. My other option was to add these graphics in the Nextion display, and I decided this would be the best option to design these screens. I also designed some other graphics for some overlays for the buttons that I'll be displaying on the touchpad screen. After all the artwork was designed in Photoshop, the image was saved as JPEG or PNG files and downloaded into the Nextion software. The Nextion Editor software is used to design the pages. In the upper left-hand corner box enables you to type what type of field you want to add to the screen, whether it's a text field, a data field, a button, or even a picture. After you added a data field to the screen, this lower right-hand box enables you to set the parameters for that box, whether it be the color of the box, the type of text, the size of the text, or the actual text itself, or the parameters for the pictures or images you're adding to the system. I begin by first adding the background image into the screen display. This is the background that was created in Photoshop. I'll be using multiple pages of screens for this system, therefore I will download this background image to all the pages. So first I select the text field to be added to the screen, and then I change the value inside this field to say Automated Accu-Slice System, and then I change the parameters to have a clear background, and then change the color of the font so it shows up on the screen. Next, I add a variety of text fields, data fields, buttons, slider bars to the screen depending on what is required for that page. The first page that I need to start working on is the data input screen. I need to input data fields for the forward and reverse speed of the main linear ball screw. I also need values for the thickness of the boards being sliced, as well as the bandsaw blade kerf thickness. The operator needs to be able to input this data into the screen, and he must be able to adjust or change these values at any time. In the previous prototype version of the Automated Accu-Slice system, I used a potentiometer to input these data fields. So my first idea was to use a slider bar to input the data as shown here. The slider bar was set up to enable the value entered to be downloaded to the Arduino board, and then I wrote the Arduino software program to receive the data and store the values for the operation of the system. The system worked quite well, but it had the same shortcomings as using the potentiometer, and it was difficult to input a precise value when the range of options was long, such as when the board thickness can vary from 0 up to ½ an inch. So I decided to find a more accurate method to input data into the screens. The second method I developed was to create data fields with plus and minus keys to change the value, one digit at a time. Default values were initially input into these fields based on my experience using the Accu-Slice system. Then the operator can push the button to increase or decrease these values. The data is then stored into the Arduino system and the values stored for the operation of the Automated Accu-Slice system. Because these fields take up less room on the screen, I was able to add two additional data fields, the board length and the number of boards to be cut. The first design of these pages for the input of data using the slider bars required 6 pages for the operator to input all the data. This new design requires only 4 pages. Again, this method of putting input data worked quite well. However, the Arduino software program was fairly long to accomplish this task. It was over 300 program steps, but it was fairly easy to program since most of the data was just duplicated for each of the plus and minus buttons. For this method, I required 4 pages for the system: a main page, a data inputs page, a manual operation page, and an automated operation page. I discovered that Nextion software had a keypad feature to enable the data to be manually keyed into each field, so I made a third method for data entry, in which I did not need the plus and minus buttons. In making this change, I was able to design a package which will just use 3 pages, and I probably could even reduce it to 2 pages since the first page or home page may not really be needed. However, I could use this home page to show a short video or include instructions on how to operate the system. By operating the Nextion software in the debug mode, I can demonstrate how it would actually operate and look in the display module. Shown are the 3 pages for the system: the main page, the manual entry data page, and the auto run page. On the auto run page, I can demonstrate the actual inputting of data into each of the fields. Again, these fields are previously populated with the normal operating data based on my experience. But the operator will frequently want to change these values depending on the hardness of the board and the length and thickness of the boards being sliced. To change the values, the operator just clicks on the field and a keypad pops up. You can then delete this field and then add new data as required. When the data is complete, you just press OK to enter the new data in the field. When all the data fields are correct, you just press the top button to upload the data to the Arduino board. This field changes color for a few seconds to confirm that you processed the data to the Arduino board. Also note the 3 buttons on the bottom of each page that are used to move between pages. By clicking on any of these buttons, you are processed to that page. This is the first of the 3 pages for the system. On this first page right now, I just have a picture of the Automated Accu-Slice system, but I'll probably change this in the future to contain a short video or possibly instructions on the operation of the system. The second page of the system is designed to manually move and position the linear ball screw and the indexer on the Automated Accu-Slice system. The buttons on the left are used for jogging the system, so you just press and hold the button to move the indexer or the linear ball screw in the correct direction. As soon as you release the button, it stops moving. With the buttons on the right, called Run, this moves the linear ball screw continuously until you either stop it with the stop button in the center of the screen, or it reaches the end of the travel with the Hall magnetic sensor. This page is needed in order to set up the system for your first cut. You first set up the starting position to cut the board by setting the board at maybe an inch from the bandsaw blade. Then you set the indexer by moving the board against the bandsaw blade to adjust the position for the indexer. I still need to add some buttons fields in this screen to enable you to download the values for the linear ball screw and the indexer to the Arduino system. After the board has been aligned in the previous page, then you use this page to change any fields you need to change for the operation of the system, such as your forward speed, reverse speed, the length of the board you want to cut, the thickness of the board you want to cut, and even the number of slices you want to cut. After these data fields have all been corrected, you then download those to the Arduino board. And then you're ready to actually operate the system. Then you start the system by pressing the Start button at the top of the screen. The data fields on the right side of this display will indicate the X and Y position of the linear ball screw and the indexer, and will also display the number of boards that were cut and the number remaining to be cut. I also added a field to show when the system is running. In this case, it is marked as being off, but I'll probably have this field blink and also change color when it's actually processing and cutting of a board. There are also two buttons on the screen to pause or stop the operation of the system. These buttons will be duplicated with actual mechanical push buttons on the electronics console. This will be a brief description of the Arduino software program to interface with the Nextion display. The software is not complete at this time, since I still need to generate the software to operate the Automated Accu-Slice System directly. Also, I only generated the information for the data entry page for the Nextion display. I still need to generate the additional code for the other Nextion pages. This first set of variables are the fields for the data that was generated by the Nextion display. These fields are changed and updated whenever new data is downloaded from the Nextion display. This next set of variables sets the default value for these variables. The remainder of the software code is for the transfer of data both to and from the Nextion display. This section of the code is really the heart of the system. In a series of fields, first of all, downloads the data from the Nextion display, that's the get value number, and then I have a set of fields to change the button colors and blink it, and that's the serial print functions here for B1. And finally, I'm using a serial.print function to display data to my serial monitor. Again, this is just for testing purposes, and this software code will probably be deleted in the future. And this code is repeated 6 times for each of the fields to be downloaded to the system. This concludes this video on the design and development of the Nextion display screens for the Automated Accu-Slice System. In subsequent videos, I'll continue to describe additional improvements to the software, as well as the design and development of the electronics console. Once again, thank you for watching this video. If you have any questions or concerns or comments, as always, please give us a call or drop us an email. We're always happy to hear from you. Thank you.